Success Arena Academy. In today's video, I'm going to be showing you one of the most set question, the most repeated question in chemistry under electrolysis. I'll be explaining it to you for today's class. Now, I see that a lot of students have sent me messages on YouTube that I should help to create a video on what electrolysis and thermal chemistry. So I'll be starting today's class with what electrolysis, but what I brought today are the 10 most repeated questions in electrolysis, and these questions are always confusing for students, whereby many students keep it when they see these kind of questions. So I'll be making it to be simplified for you. Thank you for watching. If you are new to my channel, don't forget to click on the subscribe button and also click on the like button to like my video. Drop a comment for me in the comment box section today. Thank you so much. Let's continue. Now I'll be starting today's class with the first question on electrolysis, where I'll be explaining to you what you should understand under electrolysis. Majorly, questions are always set under the theoretical part of electrolysis. And what are the theoretical part of electrolysis where questions are being set? The major theoretical part of electrolysis is the electrolysis of different compounds. What you need to know about the electrolysis of different compounds, nowadays there is not much of calculation, more of theory than calculations are found in JAM. So you need to understand the theoretical aspect of it than the calculative aspect of it. I never said you shouldn't read the calculative aspect, but the theoretical aspect is more important for now. Now let's start with this first question that I want to make research on. The first question said, during the electrolysis of copper 2 sulfate. Now, copper 2 sulfate is a solution of CuSO4. Take note of this. They said during the electrolysis of copper 2 sulfate between platinum electrode. Now, the electrolytes is copper 2 sulfate, while the electrode that is used is platinum electrode. I'll be explaining something to you here you should understand. Platinum electrode, if litmus solution is added to the anode compartments, A, the litmus turn blue but no gas is evolved. B, the litmus turn blue and oxygen is evolved. C, litmus turn red and oxygen is evolved. Let's try to explain this to you. There is something I want you to know during the electrolysis of copper sulfate using platinum electrode. Sometimes the question might be given to you as electrolysis of copper sulfate using copper electrode. What should you know about this? We are coming there. Now, in the electrolysis of copper sulfate using platinum electrode, there is something I need to know. There are 3 factors that affect the discharge of ion in an electrolyte. One of the major factors is number 1, the position of the ion in the electrochemical series. Position of ion in electrochemical series. Number 2 is the concentration of the ion. And number 3 is the nature of electrode. Now these are the 3 factors that affect the discharge of ion. But this factor in the electrolysis of copper sulfate, the only factor that can be considered in this electrolysis, because platinum electrode is used, is position of ion in the electrochemical series. What are the ions that they are referring to here? Now take note of something. In any electrolyte, before electric current can be passed through any electrolyte, the first thing that will take place is that if I have in an electrochemical cell, we have an electrolyte and we have electrode. These are known as electrodes. Now, one thing is that the electrolyte is going to be dissociated into ion. For example, when I said copper 2 sulfate is just an aqueous solution in an aqueous form, and in aqueous format of this simply means it contains copper sulfate and also it contains some little amount of water. This makes it aqueous. Now, when both of them are combined together as a solution, they form an electrolyte. The first thing that will take place before discharge will take place, number 1, is dissociation of the ion. Each of these 2 ions are going to be dissociated. Copper sulfate will dissociate into copper 2 ion, and then SO4 2- sulfate ion. While water will be dissociated into hydrogen ion and hydroxyl ion. Now these are the 2 ions. Now what we should understand here is that after this dissociation has occurred, the second thing that's going to take place there is the discharge, the movement of ion. Are we together? Movement of ion to different electrodes. Now, the movement of ion to different electrodes will take place only when the two electrodes are connected to a source of voltage. Now, when we pass electric current through it, then it will make one of the electrodes to be positively charged and the other electrode to be what? Negatively charged. The electrode that is positively charged is known as the anode, while the electrode that is negatively charged is known as the cathode. Now, after the movement of the movement of ion, then the next thing is what? Now, ions are meant to move to the what? Anode and the what? Cathode respectively. Which ions are moving to the anode? Which ions are moving to the cathode? There is one thing in physics. Unlike charges tend to repel or attract each other, while like charges tend to what? Repel. Now, you see, I said the first thing, the ions are already dissociated. Now, the negative ions, which is SO4 and OH minus, will move to the anode. That's what we call this anion. Anion simply means anode ions. Now, the positive ions are meant to go to the cathode. They are coming to this cathode position here where we have both SO4 2 minus and what? Hydrogen ion. We have Cu2 plus and then hydrogen ion. Both of them are coming to the cathode. That's what we call these two cathode ions. Are we together with me like that? I'm sure you are following me one by one. Now, after these ions have been distributed, positive ion to the cathode, negative ions to the anode compartment. Now, what is the next thing that we need to understand here? The next thing is now the ions are meant to discharge themselves on the electrode. Now, for the discharge, the electrode can only take one of the ions, but we have two ions coming to the electrode compartments. All together? Now, then discharge will take place. Then the discharge now depends on this three factor. But the major factor that we normally consider, if the solution is not concentrated, and also it depends on the nature of the electrode, the kind of electrode that is used. If platinum electrode is used in solution in an electrolysis of copper sulfate, then we should consider position of ion in the electrochemical series if platinum electrode is used. Now, let me give you some words. Electrochemical series. In the electrochemical series, I think we have potassium ion, we have sodium ion, we have calcium ion, we have aluminium, I think we have magnesium ion, aluminium 3 plus. Now, after aluminium, we have zinc, and we have iron 2 plus, we have lead. After lead, we have hydrogen, then we have hydrogen and copper 2 ion. Now, this is the electrochemical series. Now, you see, normally, when I said discharge of ion, I said it depends on the position of the ion in the electrochemical series. Now, take note. Ions that are lower in the electrochemical series tend to be discharged than ions that are higher. Why? Because ions that are higher in the electrochemical series are highly reducing agents. They are reducing agents. While ions that are lower are highly oxidizing agents. Altogether, so ions that are lower tends to be discharged than ions that are higher in the electrochemical series. Now, this is the positive series. We also have the negative series. We have our standard form, fluorine ion. We have SO4 2 minus. We have NO3 minus. We have our Cl minus. We have bromine negative. We have iodine negative, and then we have OH minus. Now, this is also anion electrochemical series. These are the cations electrochemical series. So ions that are lower tend to be discharged than ions that are higher in the electrochemical series. Now, if you take a look at this here now, I said this one moves to the cathode compartment, and this will move to the anode compartment. Now, which of them will be discharged? Now, in this place here, copper tends to be discharged. Why? Because copper is lower than hydrogen in the electrochemical series. If you take a look at it there, copper lower than hydrogen. So copper will be discharged at the cathode. Here, copper will be discharged. While at the anode here, OH is lower than than SO4 2 minus. So because of that, OH is going to be discharged at the anode. Now, let's now take a look at the reaction at each of the electrodes. Now, at the anode, take note. At the anode compartment, I said OH will discharge. Simply means the anodic reaction should be OH negative to give 2H2O plus oxygen gas plus 4 electrons. Now, it simply means at the anode, oxygen gas will be liberated at the anode. Oxygen gas will be given off at the what? At the anode. But there is what is a problem? I want you to take note of that. Now, at the cathode, what will be discharged? We said because copper is lower than hydrogen in the chemical series, copper tends to be discharged, while hydrogen will be left along within that what? Compartment without discharge. Hydrogen will be left in that compartment without what? Discharge. So, in this case here, copper, because when copper gets there, the only thing that copper is doing is a positive charge. The function of copper is to get to the cathode and receive and gain electron. So when it got there, it gained 2 electrons to itself. Now when it gains 2 electrons, it becomes copper, ordinary copper. Now in this place here, OH minus loses electron to the anode. Now what takes place at the anode and what takes place at the cathode? Let me try to explain. At the anode here, because electron is being lost at the anode, I want you to take note of this. Oxidation will take place at the anode. Oxidation reaction take place at the anode compartment, while at the cathode compartment, reduction reaction take place. How do we know that oxidation take place? Now take a look at this. You can use these formats. Cathode means reduction, or anode means oxidation. Cathode reduction, anode oxidation. So oxidation takes place at the anode, while reduction takes place at the what? Cathode compartment. I want you to take note of that. Now, let's now move back to our question. I think we are good to know about this. Now, but there's something here. I said at the anode, OH is discharged. If OH is discharged at the anode, there is problem. Now, normally, water is always in equilibrium with its ion. It is in ionic equilibrium. You know, hydrogen ion plus hydroxy ion formulates what we call what? Water. And this reaction is always a reversible reaction. Now, hydrogen ion plus hydroxide ion formulated what? Water. Now, if OH ion is discharged, then equilibrium position of water will be disturbed. Are you getting me? So the equilibrium position will shift to the right. In what way? It simply means water molecule will be what? Will be what? Dissociated to produce. If OH is discharged, water molecule will be dissociated to produce more of hydrogen ion. Because OH is discharged at that cathode. So where is it discharged? It is discharged at the anode. Now, if OH is discharged, more hydrogen ion will be produced at the anode compartment. Don't forget that at that anode compartment, it is 2 ions that move there. SO42 minus is still standing at the anode compartment. Now, if SO42 minus is standing at the anode compartment, what is going to take place? What is going to take place there is that I said hydrogen ion will be produced. That hydrogen ion that is now produced will react with SO4 minus. So the production of hydrogen ion will react with SO42 minus to produce H2SO4, which is an acid. Simply means the anodic compartment will be what? Acidic in nature. Are you getting me? Anode compartment will be what? Acid in nature. Now I want you to take note of this because this question is kind of what? Trickish. Now why is it trickish? In the sense that they said, doing electrolysis of copper 2 sulfate solution between platinum nitrate, if litmus solution is added to the anode compartment, if litmus solution is added there, don't forget I said at the anode compartment, it is what? Acidic. It is what? Acidic, not alkaline in nature. So if litmus paper is now added to that what? Anode compartment, there is something I want you to know. A litmus, an acid will turn litmus paper from blue to what? Red. While a base or alkaline will turn red litmus paper to what? Blue. Now, if the anode compartment is what? Acidic, it simply means blue litmus paper will be what? Red. That litmus paper will be changed to red altogether because of what? The compartment is acidic in nature. So let's check our answer. Option A, they said the litmus paper turned blue, but no gas is involved. Now, option B, the litmus paper turned blue and oxygen gas is involved. Option C, the litmus paper turned blue and hydrogen gas is involved. Now, option D, the litmus paper turned red and oxygen gas is involved. That is the correct option. Why? Because I said in the anode, oxygen gas will be given out because of the what? Reaction that is here altogether. And also, due to the acid that is formed in the anode, what will happen? the litmus paper will turn red. So that is the answer for that. I think we are good to go about that. Let's take a look at the next question under what? This same year, another year. This question has been repeated more than twice. Are you getting me? In JAM. Now, and I want students to understand what is there. Question 2, they said, which of the following statements applies during the electrolysis of sodium hydroxide solution using platinum electrode? Now, I want you to understand something. We have two forms of, there are different kinds of electrode. But you see, platinum electrode and graphite, which is carbon electrode, are majorly used in electrolysis. Why do we majorly use them? Because they are both known as an inert electrode. Why do you know that? The inert simply means electrode that does not react with any other forms of what? Electrode. And they are not what? They don't attack any kinds of what? Ion. Now, these two electrodes can only be attacked by, this platinum can be attacked by chlorine, and then graphite can be attacked by oxygen. So any position where oxygen will be produced, graphite will not be used there. Any position where chlorine will be produced, platinum will not be used in that position. That is the only ion that can attack them. Altogether, the only gases that can attack these two are chlorine and oxygen. So they are majorly known as what? Inert electrode, because they don't react. Altogether, now look at question 2. They said, which of the following statements applies during the electrolysis of sodium hydroxide solution using platinum electrode? Option A, sodium ion are discharged at the cathode. Option B, hydrogen ion are discharged at the anode. Option C, the concentration of sodium hydroxide decreases at both electrode compartments. Option D, the concentration of sodium hydroxide increases at the cathode only. Option E, the concentration of sodium hydroxide increases at the anode only. Let's take a look at the analysis of this sodium hydroxide. Whenever they said sodium hydroxide solution, I think in 1 year, they don't use sodium hydroxide because another name for sodium hydroxide, the way they said the question in another year is that instead of using sodium hydroxide, they call it caustic soda. Caustic soda. They said in the electrolysis of caustic soda, they are still referring to sodium hydroxide. Why? Because sodium hydroxide is known as caustic soda. So they said in the electrolysis of caustic soda, which is sodium hydroxide. Now I want you to know something here. Now, what do we need? We only need the anode reaction and the cathode reaction, so that we'll not be wasting much of our time. Now, don't forget I said whenever I say sodium hydroxide, it is in aqueous format. Except the question signifies that what is in molten state. In molten state, that means there should be what? Water. But majorly, when I just sodium hydroxide, they are referring to what? Aqueous state. And aqueous state simply means water should be included. Now, if sodium hydroxide is associated, it's going to form sodium ion plus what? OH minus. Water will associate to form hydrogen ion and OH minus. Don't forget I said these two here, they are going to the, because they are positive, they should be moving to the negative electrode, which is cathode. They are going to the cathode, and this one are negative, they are moving to the what? Anode compartment. All together. Now, you know the same ion, that means OH will be discharged. Now, what will be discharged here is OH. At the anode, OH will be discharged. And if OH is discharged at the anode, OH is discharged, what will be produced? Don't forget I said, if OH is discharged, then there will be production of oxygen gas plus what? 4 electrons. Altogether. So oxygen gas will be produced at the anode, but at the cathode, which of these two will be what? Discharged? Don't forget that we said, if platinum electrode is used in this electrolysis here, now, we are going to consider the position of ion in the electrochemical series, and we also know that hydrogen ion is lower than sodium ion in the electrochemical series. I will get up like that. Then hydrogen ion will be discharged. Now, hydrogen ion will be what? Discharged. Simply means hydrogen gas will be produced. Now, if hydrogen ion is discharged, don't forget that there will still be left over sodium ion. And I want you to know something. Hydrogen ion is going there to accept electron. Don't forget that oxidation takes place. Reduction takes place at the cathode. So hydrogen ion is going to accept electron to formulate hydrogen gas. So hydrogen gas will be produced, but there is a problem. What is the problem? The problem is that if hydrogen ion is discharged, altogether, if hydrogen ion is discharged, then it's going to disturb the ionic equilibrium of water. So ionic equilibrium of water will be disturbed. Simply means at this cathode compartment, more hydroxyl ion will be produced due to the discharge of hydrogen ion. So more hydroxyl ion will be what? Produced. And if more hydroxide ion is produced, don't forget that there is 6 sodium ion in that cathode. So the production of hydroxide ion will react with that sodium ion that is left here to formulate sodium hydroxide back. So what is happening there is that what? At the cathode, concentration of sodium hydroxide will increase at the cathode. Why? Because of what? The production of OH minus. So concentration of sodium hydroxide will increase at the cathode. Let's take a look at the option. Option A, sodium ion are discharged at the cathode. No. Sodium ion cannot be discharged. Hydrogen ion are discharged at the anode. No. The concentration of sodium hydroxide decreases at both electrodes. No. The concentration of sodium hydroxide increases at the cathode only. The concentration of sodium hydroxide increases at the what? Cathode only. Now, simply means at the cathode only, concentration of what? Sodium hydroxide will increase. That is the answer to that question. Now, the next question that I saw here that is mostly important because they repeat this same question again for students. Now, let me try to read this. I think the question goes thus. That's our question 3. I promise you I'm going to give you 10 questions that were repeated question in the exam. Take a look at this. They said in the electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at the anode and cathode are, even though without reading the option, let me try to explain to you. Whenever they said dilute sulfuric acid, they are referring to electrolysis of water. And the electrolysis of water will mean H2. This is the electrolyte that is used in the electrolysis is H2SO4. Don't forget that it is dilute. Dilute simply means it has water in it. Are you getting it? Now, if it is concentrated also, it has water in it. Now, what is here is that what? Let's take a look at the anode and the cathode as we want to do normally. At the anode, hydrogen, you know this one is going to dissociate into what? Hydrogen. Sorry. We have what? This thing will dissociate into hydrogen ion and SO4 2 minus. And then this one will into what? Hydrogen ion and what? OH minus. Now, what will happen is that which of them will go to this one will go to the cathode, this one will go to the anode. I'll get to one now. This one is the cathode electron, this one is what? Anode. Now, when this one gets to the anode and this one gets to the cathode, don't forget that hydrogen ion will be produced here. Hydrogen will be discharged, hydrogen ion will be discharged. Then, at the cathode, hydrogen gas will be produced. While here, OH minus will be discharged. If because it is lower than SO4 in the electrochemical series, so when it is discharged, take a look at it here. So when it is discharged, it simply means oxygen gas will be produced. So what will happen here? At the anode, there will be production of oxygen gas. At the cathode, there will be production of what? Hydrogen gas. Let's take a look at the option. The option said anode. The gas that will produce at the anode A. So we have sulfur at the anode, hydrogen at the cathode. B. Hydrogen at the anode, oxygen at the cathode. C. Oxygen at the anode, hydrogen at the cathode. So anode will be what? Production of what? Oxygen, while cathode will be production of hydrogen. That is another question I so much love. Now, another question that I saw when I was making my research, and I saw that these questions are just repeating themselves. But see yet many students don't understand it. Now, look at this. I think they drew something for us. Using this, they drew an electrolyte. This is the battery. Sorry. Now, they drew a battery for us, or like an electrochemical cell. This is an electrochemical cell. Thereby, we have the electrolytes that is here. This is the positive electrode and the negative electrode, the both of them. Now, and we have a bulb here. A bulb is found in this place here. Now, the solution, the electrolyte that is used is copper sulfate. The same as the first question that I got for you, but in different manner. What is the question all about? Let me read it. They said, which of the following changes are observed? A. The bulb lights and copper is deposited at both electrodes. Sorry, let me start from the question. They said copper sulfate was electrolyzed using the apparatus. Now, what kind of electrode are used? The two electrode that was used is copper electrode. I love this question. Copper electrode. Don't forget that the initial question, the question one that I explained initially, the electrode that was used in copper sulfate is what? Platinum electrode. Now, what about if copper electrode is used? Let me analyze this for you before I read the option. See, if copper electrode is used in electrolysis of copper sulfate, then I will never consider the position of a ion. Are you getting me? Why? Because this is the electrode used is the ion is the ion of the what? Electrolyte. The electrode used is copper, which is the ion of the what? Electrolyte. Now let's take a look at the compartments. Copper sulfate is Cu2 plus and SO4 2 minus, and hydrogen ion and OH minus. Don't forget that is the form of aqueous. Now these two here are the anode. Two things that will go to the anode. What are the two things? Two ions that will go to the anode. SO4 2 minus will go and OH minus will go. At the cathode, what are the ions that will go there? We have what? Copper ion will go. I get what I'm saying. Copper ion will move to the cathode, and hydrogen ion will also move to the what? Cathode. Now, let me start with the cathode. Copper ion is lower than hydrogen ion in the series. What happens? Copper ion will be discharged. This one will be discharged. Let me take like this. Discharge. Now, which of them will be discharged? Copper will be discharged to formulate what? Copper. I get what I'm saying. So copper will be produced at the cathode. You got what I'm saying? Now, in the anode, these two here are moving to the anodic compartment. Don't forget that the electrode used are both copper electrode. Now, both of them will move to the anode, but there is a problem. Normally, OH is going to be discharged at the anode because of what is lower. But when both of them move to the anode, none of them will be discharged. Why? Because the electrode that is used is the same as the ion in the electrolytes. So because of that, copper ion itself, copper electrode at the anode, will go into solution. Are you getting what I'm saying now? That means it is going to be reduced into the what? Solution, forming more of copper, and it will be deposited on the cathode. Are you getting what I'm saying now? So more of copper will be reduced and it will be deposited on what? Cathode. Now if this electrode, this anode electrode is going into solution, it will be reducing and be depositing itself on the what? Cathode. Depositing on what? On the cathode. Until all the whole copper here will be what? Reduced completely, and all of them will be deposited at the what? Cathode. Are you getting what I'm doing here? Why? We normally consider the condition that we are considering, the factor we are considering there is what? The nature of the electrode. This factor is always considered only, nature of the electrode is always considered only when the electrode used is the ion of the what? Electrolyte. Then we consider the what? Nature of the electrode. Let me take a look at the options. Option that is there, option A. Okay, before I move on, you know there is a bulb here. Are you getting what I'm saying now? Now, the bulb is going to light up. Why? Because electrolysis that will take place. The bulb will light up normally. Now, let's take a look at the option. Option A. It said the bulb lights and copper is deposited at both electrodes. No, copper can only be deposited at what? No, cathode, not at both electrodes. This one will reduce and be deposited on what? Cathode. Option A is wrong. Option B. The bulb lights and copper is deposited at the anode and disappear from the cathode. Is that so? No. Now, this is the anode. The copper is going to disappear from the anode and deposit itself at the what? At the cathode. So, it simply shows our answer is option C altogether. So, it will light up the bulb, but all the copper at the anode will disappear and they will move themselves to the what? Cathode. This is another way of what? Answering their question. Now, the fifth question, number 5, is they said an example of strong electrolyte. This is common. An example of strong electrolyte is we have ethyl acetate, we have ethanol. Option C, we have glucose. Option C. Option D, we have sodium fomate. And option E, we have formic acid. We have ethyl acetate, ethanol, glucose, sodium fomate, and formic acid. Now, you see, strong electrolytes are majorly ions of sodium. Sodium ions are what? Strong electrolyte. So, sodium fomate is the strongest electrolyte among everything that is here. The rest of them, they are what? They are weak electrolytes. Ethyl, ethanol, glucose, formic acid, they are all what? Weak electrolytes, except sodium fomate. Why? Because sodium fomate is just like in form of an ester. Are you getting something now? So that is that. Now another question that they asked that is so much low, which is the question 6. They said, which of the following statement is correct during the electrolysis of caustic soda solution? Caustic soda, I think I've explained this before. In the first question I asked, they said sodium hydroxide. Now they now said caustic soda, which is the same. Caustic soda. So in the electrolysis of caustic soda, altogether, that is the electrolysis of sodium hydroxide. That is caustic soda. They say which of the following statement is correct
Option A, gas is given off at the cathode. Hydrogen gas is given off at the anode. Option C, sodium metal is deposited at the anode. Sodium metal is deposited at the cathode. And E, alkalinity at the cathode increases. The only solution that you need to do to this is that the same way I normally wrote everything. You are going to write anode and cathode. Are you getting me? You know that sodium hydroxide will be sodium ion. Sodium ion will be going to where? Positive. This is sodium ion. And also we have hydrogen ion. This is hydrogen ion. Then this one was OH minus, OH minus. We'll move to this. Now, what is going to happen here is that what? Hydrogen ion will be what? Discharge. And this one, your OH will discharge. Simply means oxygen gas will be deposited here. Oxygen will be deposited here. And hydrogen gas was deposited in this place here. But if hydrogen gas is deposited, what will happen? More of OH will be produced. Now I say if hydrogen gas is deposited, OH will produce, and that OH will react with sodium to form sodium hydroxide, which will increase the alkalinity of the cathode. Let's take a look at the option. Option A, oxygen gas is given off at the cathode. No, oxygen gas will be given at the anode. Option B, hydrogen gas is given off at the anode. No, it's going to be given off at the what? Cathode. Option C, sodium metal is deposited at the anode. No, it is hydrogen ion that is deposited. Why? Because it is lower than sodium in the electrochemical series. Option D, sodium metal is deposited at the cathode, which is no. Are you getting now? Sodium metal cannot be deposited in this kind of electrolysis. But option E, alkalinity at the cathode increases. Don't forget I said at the cathode, more OH will be produced, which will react to sodium ion that is left at the cathode compartment, which will increase the sodium hydroxide concentration. That is question 6. Thanks for watching this video. Please check and recheck this video again so that you can understand all what they normally use to confuse you in JAMB. Anyway you don't understand, drop a comment for me in the comment box section below. I'm going to attend to your questions, everything. All together, thank you for watching. Please do remember to click on that subscribe button and the like button to like the video, and also share the video with